Next, we'll take a look at testing EF Core in our ASP.NET Core API. Testing in ASP.NET Core is more complicated than is justified for a fundamentals course on Entity Framework Core. So I've already created the samples, and I'll just show you a few highlights. Like the console app, I've refactored the controller and extracted the pub context along with those helper methods that transformed author objects to author DTOs and back into its own class. And like before, I'm calling that class DataLogic. For the ASP.NET Core app, we do need to take into account that the controller methods are asynchronous. As you've seen, asynchronous programming is important for web applications. But when you've got layers of code, it can be a little tricky to coordinate. Here, for example, in my DataLogic class is a method called getAllAuthors. It queries for all authors, transforms them into DTOs, and returns a list of author DTOs to the calling method. And I've designed this method, as well as the others, to be asynchronous because now this is where we may have to wait for the database interaction to complete. And I don't want to block any UI that might be calling it, even if that's indirectly. The controller method is still asynchronous, so the cascade of asynchronous calls flow together perfectly. But the controller now calls out to this getAllAuthors method instead of using EF Core directly. So rather than using dependency injection to inject the context into the controller, as we were originally doing, now I'm injecting my DataLogic class into the controller. And to support this, the API's services need to know that it should provide DataLogic instances as needed. So back in the program file, here's that new configuration. I'm using the services addScoped method to supply a DataLogic instance that will be scoped to each request. And the DataLogic class benefits from the pub context being injected into it each time it's instantiated. Here's the refactored controller method to get a single author using its ID. Now this one calls into another new method in the DataLogic class named getAuthorById. Then the controller method returns an HTTP response along with an author DTO if it was found. The new getAuthorById method in DataLogic just uses the findAsync method that was originally in the controller. Now it's time for a test to see if this getAuthorById method actually works. I've added a test project to the solution, and in it, a test class called DataLogicTests. Thanks to the refactor, I can test these methods directly now, and I don't have to worry about running the controllers in order to test them. In order to return an author from the in-memory database, I need to supply an author in the in-memory database. If I were to call the context database ensure created method, that would honor the has data logic in the context and seed the data. But I want to use this as an opportunity to show you how you can share a DB context instance across methods. So what I'll do is use a method in the test to seed my in-memory database. And notice that in my new test, I'm sharing the same builder options object with that seed method that I'll be using to test getAuthorById. That way, both the seed and the test method will end up using the same in-memory database. Therefore, when I do try to get the author, it will find that seed data. After calling getAuthorById, I just test that the retrieved author has the same ID as the one that I seeded. I've also refactored the other controller methods, and you can explore and test them if you're interested in digging further. But for now, I'll just show you that the test that we just looked at does indeed pass. Well, that's it for seeing EF Core being used in automated tests. If you're new to testing, I hope you were inspired to learn more about automated testing, although here we focused on tests that involve EF Core. Some of the tests we wrote verified that the context was built correctly and that EF Core responded to the mappings we defined as expected. This is a really good approach to ensuring that your intention that you coded into your DB context matches how EF Core interprets a DB context. While sometimes it's necessary to test with the actual database server to see certain aspects of how your app is interacting with the database, though not against your production database, There are definitely downsides to working with a resource-intensive database like SQL Server, or having your tests rely on whether or not the database server is available. If you're not interested in what's happening in the database, this could be an unnecessary impediment to informative results of your tests. While you could use a lighter database like SQLite as a stand-in when testing, the lightest weight option is to use EF Core's in-memory provider. But do so with the understanding that the in-memory provider works with lists of data in memory, and it can only prove out limited database behaviors. So if your test really needs to know what's happening in the database or is dependent on particular behaviors of the database, then you should probably just use a database. We also refactored the demo apps to make them more testable, so that we could test the logic and not have to worry about the complexity of the console app or the ASP.NET Core API, just to see that your business logic involving EF Core does what you expect. However, sometimes you do need to validate that the integration provided throughout the app is working. But doing so is a bit more advanced. I have included a sample in the downloads if you want to take a look at it, but you'll probably want to watch a course that's more focused on testing with ASP.NET Core apps. Now that we've gotten through the basics of EF Core, the rest of this course will give you some insight into techniques and features of EF Core that dig a bit deeper but are still fundamental to your ability to use it when building software. The next module will introduce you to some additional ways to map your classes to your database. These are mappings that are important in a large variety of software solutions. Here again are some resources relevant to this module on testing with EF Core that I think you might find useful. I'm Julie Lerman, and thanks again for watching Entity Framework Course 6 Fundamentals. Hello, welcome back to Entity Framework Course 6 Fundamentals. I'm Julie Lerman. This module will introduce you to a wider variety of the mappings you can achieve in order to persist your very nicely designed classes that might not align so well with the shape of your database. But rather than being forced to change the design of your classes in order to make them easier to persist, and that's something I will guide you to avoid, there is so much you can do in the DB context configurations to bridge the gaps. As part of your fundamentals education, you should have an awareness of other possibilities with EF Core that are important to even the most basic work you might be doing. So in these last modules of the course, I'll be covering those types of topics at a high level, just to make you aware so that you know what can be achieved and to give you a quick look at some of these features. We'll begin by ensuring that you know what to expect from strings in your classes with respect to .NET's project nullability and how EF Core convention responds. Then I'll go over a list of mappings and conventions to be aware of that we haven't touched on yet. In this course, I've focused solely on Fluent API configurations, so I do want to give you a quick look at data annotations, the other way to configure mappings, and make sure that you understand why I mostly ignore them. Then I'll be sure you're familiar with a few specific scenarios that you might commonly need to address in your software, such as EF Core's support for enums, the ability to persist properties whose types don't have a direct correlation to database types for EF Core, how to apply configurations in bulk, in other words, configuring a type that might be used by properties across a number of your entities rather than just configuring one property at a time. And we'll also take a quick look at mapping complex types and value objects. Because this module is providing a high-level overview of these features, there are no exercise files to download. So sit back and soak it all in. Reference types by default are nullable, and the most common reference type that you use is a string. Because it's nullable, that means it can exist without being initialized, compared to an integer, which by default initializes itself to 0. However, having a null string can lead to the possibility of attempting to perform operations on strings that will result in a null reference exception if the object is null. Thanks to a project setting called Nullable, which is enabled on all new projects by default, the compiler will try to alert you to places where this might happen by providing warnings in your code. How it does that, however, does depend on the code. If you've created a new project and a new class with strings, you'll see the effect right away. The string properties will have warnings suggesting that you make them non-nullable. If you access methods or properties of the string that will cause those exceptions if the property is null, the compiler won't point those out because it's pointed out the properties already. But this line of code will throw an exception at runtime. And there's the possibility of explicitly making those strings nullable in the code. Alternatively, you could disable the nullable setting in the project. But with both of those paths, now you're on your own to make sure that your code is protected from the null exceptions. But why am I talking about this in an EF Core course? It's a lesson for C#. But of course, I have a reason. EF Core will map these strings based on the nullable setting of the project. Normally, you would expect a string to be nullable, and therefore the char or nvarchar column it maps to would also be nullable by default. You can always force the map database column to be required with an isRequired configuration, but keep in mind that the database is the only place that constraint will be enforced. EF Core won't do that. You'll need to ensure your business logic protects that requirement. But if you have nullable reference types enabled and you haven't explicitly made the strings nullable, then EF Core's convention will be to map that to a non-nullable column. Let's take a look back at the author class we've used throughout this course. The domain project does have nullable enabled, but I did something that I don't recommend you do, which is that I tricked Visual Studio into not showing these warnings because I didn't want you to worry about those warnings while you were busy learning about EF Core. You didn't see the warnings. Let's look at what you probably saw. When I undo my trick, the properties still don't have the warnings. But the code in my constructor does, because you can fix the problem in the constructor by initializing the strings. If I comment out the constructor, the strings now get the warnings, as well as the books property, because that should also be initialized. I'll show you a different way to initialize the books by initializing inline. So now books is fixed, but the string properties still have their warnings. Now I'll put my trick back in place and uncomment the constructor, and let's take a look at how EF Core responded to my author class. And if we look at the migration files, notice the columns that map to strings, such as the author's first name and last name. Those define the nullable attributes of the columns as false, and therefore the database columns were non-nullable.